All right, so now we're gonna do transfer learning in the workspace. Remember when we dealt with COFNETs, we were using pre-trained models, models that had been trained on ImageNet. Here we can do exactly the same. We can use an embedding space that has been pre-trained, and in our case, we decided to take the GloVe embedding space. So let me take our embeddings IMDb file and see how we can reuse the code there. Embeddings IMDb, let's make a copy. Here we go. And this here we will call transfer learning. So let's change the title to transfer learning GloVe. Here, transfer learning GloVe. Here we go. So most of the code is going to be reusable. Here we are. Nothing changes here. Also here, this stays the same. If we print out the first element of the list, we're going to get exactly the same outcome. No change for the type. Here we're just zero padding or truncating the reviews. This is still an array. And now we're at this stage, and here we need to make some changes. All right, so now we're gonna use pre-trained model GloVe, and basically the GloVe embeddings you can find on the internet. It has a vocabulary of about 400,000 words. And the embeddings vector sizes go from 50 to 100, 200, and even 300. We will choose the 50-dimensional one. And the trainable parameter we set to false to see if our model has improved with the previous session, compared to the previous session. All right, so now we gotta go to the internet here. Let's go to Google search. And I'm keying in GloVe. Here we are. That's a Stanford site, so I open that. And the file that I'm gonna need is this one here, glove6b.zip. And you can see here on the top right corner that the computer is downloading the file. All right, file is downloaded. So now let's see that we can move this file to our Google Drive. So I go to Google Drive, and then I'm gonna upload it on my drive. And maybe it's best that I go into Colab Notebooks first before I do the upload. I don't see the file anywhere here, so file upload. And here is the one, so the GloVe 50. So let's do this. So it's actually downloading relatively fast. All right, so now I can see the file here, and I should be able now to access the file through my Colab interface. But I will have to mount Google Drive, and here you see Mount Drive. If I just click on it, it will immediately paste the code. Yeah. So let's run or connect Google Drive. I have to first get my code. Here we go. Copy this code. All right. Paste it, and then press enter. Now once the drive is mounted, I should see, let's do a refresh, I should get access to that file. Now let's see if I can find the file here. Oh, here it is. All right. So I can access the file here, and now we are ready to extract that file or to upload that file into our program so that we can use the pre-trained covenant. All right, so before we start importing that pre-trained glove model, here is a glimpse of what this text file looks like. So here you have your word, and then after the word you have a series of numbers. And this should be exactly 50 numbers, as we want to have a 50-dimensional embedding vector. Now, one word that we're gonna look for is Sandburger. So let's do a search here, and we find this here on the left bottom. And you see the word vector starts with 0.072 and ends with 0.55559. Yeah, so let's keep that in mind. All right, so now what we're gonna do is basically upload the text file into our program. And at the end, what we wanna have is we wanna have an embedding matrix for 7,500 words and of length 50. So let us start with this block of code. Here you see we create an empty dictionary. Remember, in Keras, an embedding layer maps an integer to a dense vector. So we're gonna open that file. So I gotta go to the left lower corner and do a copy path by right-clicking. And then I'm gonna paste that between these two quotes. So now we can open the file. And for every line in F, so we're gonna go through that file F, and we're gonna do a line split. And this split, what it will do is it will create, or it will convert whatever is in the text to a list of lists. Yeah. And one element of the list is gonna be containing the word, and this will be index 0. So for each list item, you have a list, and at the 0 index, you're gonna find the word. And the other values, meaning here from 1 to the end, will basically be your weights, and these will be the numbers. And of course, the type of these is float32. Yeah. So let us run the code first, because I print the length of the embeddings dictionary, and we will see that it's 400,000. Yeah. We actually only need 7,500, so we'll need to do some work. What I want to show you is how these values are looking. Values, let's take values 0. Let's print that. That's the word. Yeah, that's typical, because index 0 is a placeholder for the word. If we take from 1 to the end, we basically gonna see the embeddings for Sandburger, and we've seen them before. Exactly this number we recognize, and at the end, this number we also recognize. So that's exactly what we want. Index 0 is the word Sandburger, and index 1 to the end, and the end will be 50, are gonna be these numbers. And you see here that this is still a list, yeah, because it's between quotes. All right. Now let us take a look at this thing here. Embeddings dictionary word will give you the weights. Yeah? So let's do print embeddings dictionary, and let me put a value here. The value is Sandburger. Yeah, and that should basically give us the weights. Again, it should give us the same as we have in the previous slide. So here you go. The only difference is that in this case, yeah, we have made a matrix. Here the weights are a matrix of type float, and this is exactly what we get here. So we're on the right track. All right, so let's continue now and prepare our glove matrix. So I'm gonna add this block of code here. Define our matrix, and it's a matrix of 7,500 words, and the embedding size is 50. So I'm gonna loop in the second row here. You're gonna loop through the directory. So you're gonna loop through the values and the keys. And basically what we're gonna do is we're only gonna look at the most frequent words. So all indices up to 7,500 instead of 400,000, yeah, which we had before this block of code. And basically what we're gonna do is we're gonna have an embedding vector, and the embeddings dictionary get word returns the value for a given word. Yeah, the value in this case will be all the numbers. And if the vector has a value, it will be added to the matrix at column I. Yeah. So let us do some checking here. So print embedding matrix, and we're gonna take at column 0, and here we should see the matrix. Yeah, here you see all the numbers, and these still look familiar to us because that's the word Sandburger. Okay, so that will be the first column vector in my matrix. All right, so let's now start building our model. I'm gonna run this block of code that is very similar to what we've seen. So we have 3 types of layers: embedding, dense, and flatten. And here the embedding layer, 7,500 words. The dimension of the embeddings is 50, and the input length is 150 words, is max length. So then we're gonna flatten and then create a dense layer with relo activation that will eventually go into a sigmoid. And we can run this block of code. The next thing that we need to do is basically we need to set the weights in layers 0, meaning our first layer, which is this embedding layer. Yeah, we set the weights as per our embedding matrix. And we set the trainable parameter to false. Yeah, the whole purpose of working with these weights is to rely on GloV embeddings. So if we make these trainable, I mean, it would defeat the purpose. So let us run this block of code. Here we go. No problem. So now we're ready to compile RMS prop, cross, entropy, and accuracy. All right, let's run this. And now we are ready to fit our model. Here we go. 10 epochs, batch size 16, and 20% validation. So let's run this. All right, we're done training, and you see validation accuracy is in the low 50s. Doesn't do really well. I copied these 3 blocks of code as we've used this many times before. So let's take a look at the graphs. Here we are. The validation accuracy, as you see, it's pretty much flat from the start. So there's definitely overfitting happening as well.